was explain why the following statement is true or false. If the radius of the circle doubles, then the arc length with the associated with the fixed central angle doubles. So I'm going to explain first where we derive the formula for arc length. So the circumference is the perimeter of a circle, and the formula is 2 pi r, where I like to think of it as it takes 2 pi or around 6.28 radii to get the length of the circumference. So an arc length is a portion of the circumference. So how we express the portion is by replacing that 2 pi with an angle in terms of radians, because again, 2 pi is an angle measurement in radians. So we get the formula S, which is arc length, is equal to the radius times the measurement of the angle in radians, which is theta. The formula, or how I like to think of it, is that it's saying that the angle creates this portion of the circumference, which is the arc length, which is equal to a certain amount of radii. So if we put this in terms of values, let's say I have the central angle of 1 radian, my arc length would then be equal to the length of 1 radius. So if I have a radius of 5 units and the angle measurement is equal to 1 radian, then my arc length would also be 5 units. So to answer the question, if we were to double the radius, keeping the central angle the same, would my arc length double? And the answer is yes. So expanding on my previous example, if I keep the angle measurement 1 radian, then I double the radius to 10, I would get 10 as my arc length, which is double my previous arc length of 5. And then in my example to the right, I used the angle measurement of pi over 2 radians, or a 90-degree angle, and I used 5 and 10 again as my radiuses. You can see that when I plug in those values into the formula for doubled radius, the arc length of 5 pi, which is double 5 pi over 2. So I guess to summarize, when I double the radius and keep the angle the same, I'm doubling the arc length. Any questions?